Moving on from the blown over leaf scroll, we're going to move to the square corners. There are two of them. And saying they're square corners is perhaps a slight exaggeration. They are close to being square corners. I think if we look at them, they're actually a little more open than 90 degrees. I like to measure the square corners through the center line of the stock because that's the constant, it doesn't move. So let's have a look and see what we can work out. I'm going to draw two 45-degree lines across the corners and center punch those. And I'm going to measure that distance. That's the center line, that doesn't move. The inside and the outside dimensions will both change, and they'll change half the thickness of the material per side. So 1/4 of an inch this side, 1/4 of an inch that side. Total 1/2 an inch. Same with this, it'll move 1/4 of an inch this side, 1/4 of an inch that side, total 1/2 an inch. So as that's a moving target, I'm going to stay with the center line, which is a constant. I'm going to place my dividers on the center line and measure to the other center punch on the center line, and then I'm going to measure that against my rule, and I've got 2 1/8 inches. I don't like working from the end because that's worn on my rule, so I come in 1 inch and then subtract an inch from my end result. So I have 2 1/8 inches between the center line, the 45-degree angle of the upset square corners. You'll notice as I set my square here that the corner is not 90 degrees but open from 90 degrees right down to the root of the corner. If I generate a 90-degree upset square corner bend and then try to bend it to create the scroll, that stress in bending is going to be concentrated right here at the stress riser, or concentration of the stresses, and we'll end up generating a crack right there. So I like to forge mine slightly open, and then I've already started the bend for my scroll work if I need to. You'll notice, I hope, that I have two center punch marks, very distinct on this side because the area hasn't been forged, and on this side not so distinct, it's going to be right there, where I forged the square corner bend. Hopefully that center punch mark is on the diagonal, and you can see there, of the corner, so it's in the right place. These are 2 1/8 inches apart, exactly the same as the distance between our two center punch marks on our drawing. Where these two center punch marks are relative to the whole bar is a factor of determining how much material is needed to generate this scroll, and then leaving that from the end. Certainly we can start in the middle of a bar and just put two square corners and then chop off what we don't need, but at some stage we have to make a cut if we're going to do a taper to a weld. So we need to know how much material is involved in that portion of the scroll. Before I can put the square corners in the bar, what I need to know is what is the distance from this datum to the datum that we established earlier at the base of the leaf. And to do that, I'm going to use the same dividers as I used before, and I'm going to step that out. 1, 2, 3, 21, 22, 23, 23 and a half steps. Remember the steps, not inches. So we have 23 and a half steps. Now to convert those to inches, I'm going to divide that by 2, and that's going to give me 11 3/4 inches in length. And I've taken that from the datum here, midpoint along the square corner bend, up to the end of the datum here where the scroll and the leaf branch. Now we've already done some work here, we already have our piece. So from that 11 3/4 we need to subtract this material here, and I'm going to measure to midpoint along the scarf as we have this upset here ready for the weld. So I'll measure that, and I'm showing that at about 2 inches. So I take my 11 3/4 and I subtract 2 inches to get 9 3/4 inches long. Again, now this is from the datum here to the breakpoint of the weld for the two pieces. Now, because the material is a constant 3/4 of an inch wide, I don't need to worry about doing a volume calculation. I can make do with an area calculation when I'm comparing the area of this scroll to the area of my unforged stock. Now, the weld point here, I'm showing that as being 5/16 of an inch thick. I know the material here at the corner is 1/2 of an inch thick. And I'm going to divide that by 2 to get an average. Once I work that out, then I can multiply that by my 9 3/4 inches, and that will give me the area for my scroll. So the formula we're going to use, we're going to take the height of the material at height A, we're going to add that to height of the material at point B, and that's either end of that scroll that we were looking at. We're going to divide that by 2, that will give us the average, and we're going to divide times that, multiply that by the length, and we said that was 9.75. So let's plug some other numbers in here. H1A was 0.5 or 1/2 an inch. Going to add that to H1B, which was 5/16, so 0.3125. Put that in brackets because we want to solve that first. Put everything over 2 and multiply that by 9.75. Luckily I have a calculator right here, so I'm going to plug in some numbers and come back to you with a number. So what I have is 0.5 plus 0.3125, so that's 0.8125, multiplied by 9 3/4 or 9.75, and I get an answer for that of 7.92. I divide that by 2 and I get an overall answer of 3.9609 square inches. What I need to do now is compare that to the bar that we have that we're going to use our square corners, which is 1/2 an inch thick. I don't care about how wide it is because that's a constant. So I know that it is 1/2 an inch thick, but I don't know how long I need. That's the unknown. So I've got 0.5 times length 2. That's the length I don't know. I know that when that multiplies that, it should equal that because I'm trying to compare and contrast. 9.609 square inches. So if I take this and divide it by 0.5, those will cancel it out, leaving that there. But whatever I do to one side, I have to do to the other side. So I need to take that number and divide it by 0.5. I'll come back as soon as I've been to my calculator. Already could have done that because it's just the opposite to that. So I've actually got 7.92 inches equals L2. So that's the length that I need of my square bar for the upset square corners. Sorry, of my rectangular bar for my upset square corners. 7.92 inches long. I don't know what 0.92 of an inch is, but I do have a card that compares fractions to decimals to millimeters. So I'm going to look at 0.92, which is going to be over here, and I've got 0.9219 is 59/64. Well, that's not a real number for me, I can't understand that, but 15/16 I can. So I've got 7 15/16 of material that I need to measure up from. So I start from the end, come up 7 15/16, wherever that is. That's the start of my first square corner, my datum. Measure from that 2 1/8 inches. That's the start of my second corner, and I go from there. Those are the two datums that we looked at earlier. So now what this does for me is I can make these two corners knowing that I've got enough material to make that weld and taper all the way back to the transition point with the stock that I've already made. Now that I've worked out the length of material I need to make the scroll, I need to concentrate on the other end. I'm going to draw this portion down to 3/8 of an inch thick here, as the centre bar is 3/8 by 3/4 and 1/2 inch would look too heavy there. So I'm going to step out the length again from the centre here to my datum. I'm going to average out the stock size by adding my 1/2 inch to my 3/8 and dividing by 2, and I'm going to calculate this area, and I'm going to compare that to my 1/2 by 3/4 flat bar. Once I've added the material I need for this section, the 2 1/8, and the material I need from this section, that is the minimum that I require to be able to go to work. I may need to leave a little more than this so that I can hold it in the vise to make this corner, but I still know where my severance mark is on the bar before I go to work.